Hi friends and my dear students, in 12th physics, 8.5 nuclear force. New unit may be called as 9th unit, but as per in textbook 8.5 nuclear force. When we consider about an atom, inside that there may be nucleus. As we already studied about the nucleus, it is purely positively charged particles, and there may be particles available here, proton and neutron. Proton are positively charged. Here the charge of the neutron is called 0. Here the positive of the charge as proton is called positive. Now proton, neutron are very denser combined together in the nucleus itself. Okay, now the question arises, as per the electrostatic forces, one positive nucleus which will give the repulsive force to the another positive charges, even though it may be combined together in the nucleus. Why? That is the first question arises. Because within the nucleus, the electrostatic gravitational forces which will make a bond, either proton with proton or proton with neutron or neutron with proton or neutron with neutron. These four possible pairs are possible inside the nucleus. Here, and the distance between these two particles, it is about a few Fermi, minus 15 meter, minus 15, 10 power minus 15 meter, very shortest distance are separated. The distance between two protons are very few Fermi, even though what we expect, it is closer to each other. But as per the electrostatic repulsive force, the proton must be repelled to each other and get away from the nucleus. That's the thing that happened. But apart from that, all are combined together. Why? That is the reason that we have to analyze today. And what are the pairs? Here, neutron and neutron are neutral particles. Without charges, how can it repel to each other? There may be gravitational attraction forces here. So the first forces is electrostatic repulsive forces, and the second force is gravitational attraction forces here. Even though the first one is called repulsive forces, repulsive force, second one is called gravitational attraction forces. But even though now we have to explain in a detailed manner on what are the necessary conditions to explain these four combinations are combined together within the shortest range or distance, that is called proton-proton pair or neutron-proton pair or proton-neutron pair or neutron-neutron pair. That's a very fantastic phenomena that we have to understand clearly about to study about the nuclear force. What is the nuclear force? The nuclear force here, when we consider the nuclear force, they are acting between the proton and proton, or neutron with the proton, or whatever it may be the pairs like that. It is a very fantastic forces and very short range forces is greater than these two things. The first one, the nuclear force is greater than the repulsive force of electrostatic or the gravitational force of attraction. We cannot imagine such a forces are here. For example, we have to consider how much the repulsive force between two successive proton which are placed in a very short distance of few Fermi. As we already said, F is proportional to Q into by R square. Q is the charge of proton. Here the charge of proton. Now, if you put a constant, F is equal to K into Q square by R square. Now substitute the value of F is nothing but 9 into 10 power 9, and Q, the charge of the proton, that is equal to 1.6, charge of the proton almost equal to the charge of the electron, that is equal to 1.6 into 10 power 19 minus 19 coulomb whole square divided by R square. Short range 10 power minus 15 Fermi. This is the value, and here it is approximately equal to 230 Newton. So the force of repulsive force, the repulsive force between proton and proton both are repelled to each other about 230 Newton forces. This is a very fantastic phenomena that we have to consider or calculate the repulsive forces of the proton with the proton. Okay. Then how much the acceleration it will get due to the repulsive force, that we have to calculate. That is thing that we have to calculate. Now, what is the value of A? What is the value of A? That is the thing that we have to calculate. F that's equal to MA. A that's equal F by M. F by M means here force of repulsive is called 230 Newton by mass that is equal to 1.67 into 10 power minus 27 kg. 1.67 into 10 power minus 27 kg. This is a mass of the proton, and this must be equal to 1.4 into 10 power 29. 1.4 into 10 power 29 meter second power minus 2. This is the acceleration due to the force which are acting on the proton. Then this proton are repulsed to getting acceleration, getting away from this nucleus. Even though when we are talking about the nucleus, proton, neutron, or proton, neutron, or neutron, proton are combined together inside the nucleus. If you are assuming nucleus, how is it? That is, how is it possible? That's a problem that here again we have to discuss. There may be another forces apart from this. Apart from the real thing, there may be another forces which are acting here to kept in static form within the nucleus, proton or these four pairs, and that may be within the short range forces, and it is called the nuclear forces. The nuclear force. The nuclear force is a short range force within the smallest distance it may act, and it is a force which is heavier than the real explanation of the repulsive force or gravitational attractive forces. That's why to overcome these two things, then the proton and proton, or neutron and neutron, or proton neutron or neutron proton are combined together. That is a fantastic phenomena. This is the force which is the highest force in this world, as we already invented or already discovered by the scientists. Nuclear force is a very highest force. That's why this is smallest particle, proton with proton, or whatever it may be, the particles available inside the nucleus are combined together and maybe stable and form a nucleus. That is the secrecy. Nuclear force is acting. Nuclear force is acting, but the nuclear force which will not act on the electrons. It may happen only in the inside the nucleus, not outside the nucleus. That's why nuclear force are called short-range forces. Short-range forces. This is a very introduction for the nuclear forces. Now again we have three kinds of properties of nuclear forces. Very importantly, that the first one is three important forces, properties of nuclear forces. That is, to understand the nucleus, we must clear what are the properties of the nuclear forces. Nuclear forces, it is not depend on the charges. Suppose if you consider proton with proton, positive with positive, proton with neutron, positive with zero, or neutron with neutron, zero with zero. Here there is no positive, even though it make a pair neutron with neutron. So here we conclude that nuclear force is not depend on the charge, not depend on the charge, not depend on the charge. It is high forces which are impact this particle getting together or combined together within the nucleus itself. Even though it is at only up a distance of a few Fermi. Now, but inside the nucleus, the repulsive Coulomb force or attractive gravitational force between two protons are much weaker or much lesser than the nuclear force. That's the reason why these particles are combined together. Nuclear force is far heavier than these repulsive forces or gravitational forces. That's a very important concept. First point. Second point, there is strong nuclear force. Nuclear force is very strong. Very strong forces. Strong forces. It may act between proton with proton or proton with neutron or neutron with proton or neutron with neutron, irrespective of charges. That's why these four possible pairs are available inside the nucleus. This is the second important concept to analyze. The third one, when you consider about this is called nucleus. If you are imagining the electron or in the revolving in the orbital, the pairs are within nucleus itself, but the nuclear force does not any changes in the electron, so that the chemical property of the nucleus which will not be modified. Chemical property which will not be modified. This is a very fantastic phenomenon to understand the nuclear forces. I hope you understand how much the force is highest force than any other force, the nuclear forces. Okay. The next point, next we have discussed about the radioactivity. What is meant by radioactivity? These are all introduction. Then we have to analyze the concept alpha decay, beta decay and gamma decay. Before that, we have to discuss about radioactivity. Radioactivity. Activity. What is meant by radioactivity? The radioactivity, it is nothing but if you consider any element of Z and A, if you consider the nucleus or the atom like this, here Z proton and Z electron, atomic mass number are said to be A. If this is called an element. This element naturally emits some kind of particles, alpha or beta or gamma radiation. What is meant by alpha particle? Alpha particle is nothing but 2He4. It is called helium nucleus. This element which will emit one alpha particle and may be altered to another some Y element. Therefore, Z minus 2, A minus 4. This is the basic principle that you have to understand. The nucleus are converted to be as a nucleus of Y. Here, the masses of the previous one is decreases the value of minus 4 and the atomic number reduced like 2. This is called parental and this one is called daughter. This is a basic principle that you understand the alpha decay. This may be happen only spontaneously when this atom are in the excited state or unstable state, then the nucleus which will spontaneously emit the alpha particle, so that the another atom or another element which will be formed. The another element and atomic number which will be reduced minus 4 and atomic number will be reduced in the 2. That's the thing. Then alpha particle also. Here, during this process, this may be transmutation of an atom by means of alpha emission. And these elements, unstable elements are called radioactive elements. Those elements are in unstable are capable to emit spontaneously alpha particle or beta particle or gamma radiation. That kind of particles are said to be radioactive elements. Or sometimes its isotope also have the same property. Such elements are called radioisotopes. For example, 6C12 and 6C14. This is the stable, there is no radioactivity. Here it may radioactive, this may unstable. This is stable, this is unstable, and it will emit alpha, beta or gamma radiation. These isotopes is called radioisotopes. Isotopes, because this element are said to be unstable. Here the isotopes of this element is called said to be unstable, and both are called as radioactive substances. Here it may called as radioactivity. The process are both are here radioactivity. Here the element is called radioactive element. Here the element is called as radioisotopes. That's the difference. But the process are happened here are same. Here also alpha particle, beta particle, gamma radiation. Their isotopes are unstable. There are also emission of alpha, beta and gamma. This is a fundamental concept to understand the radioactivity, unstable. Radioactivity, whenever these elements are in the unstable state, not in the stable state, then spontaneously it may be happen. Suppose these elements are in the stable, then it will not radioactive. There is no radioactivity. There is no radioactivity. Then, if let us assume binding energy curve, we already studied it. Binding energy per nucleon is greater than 82. This is unstable. This is unstable, and it has a property of emission of this alpha, beta, gamma radiation. This alpha, beta, gamma radiation. Or in other words, in the smallest area, when Z is less than 28, then for example like this carbon, here it is unstable, this is a stable, this one is unstable. Here also this is element, this is not an element, isotopes of this element. This has a property of radioactive only because it is in the range of unstable. It is unstable, that's why it emits alpha, beta and gamma radiation. This is a basic concept that you have to understand radioactive particles and radioactivity. Now, so what is the necessary condition of radioactivity? Alpha emission. Alpha emission is nothing but 2He4 emission. Then beta emission. Beta is nothing but electron. Beta is nothing but electron minus 1E0. This is called beta emission. This is called beta emission. For example, emission of 0 like here, minus 1. This is called beta emission. Or you may call it as positron emission. Positron is nothing but plus 1. This is also possible in this case. Here this is called electron and this is called positron. Positron. This is also possible. Alpha decay, it is nothing but emission of alpha particle. Beta decay, it is nothing of emission of electron or emission of positron. And third one, there is no change in the mass. There is no change in the mass and there is no change in the atomic number. Only there may be variation in the radiation. Only energy radiation. Energy difference. Energy difference. This is called gamma radiation. This is called gamma radiation. Not particle. This is energy differed by means of emitting radiation of the parental atom as a and daughter atom. These three things are very important to understand the radioactive activity. Alpha emission, beta emission. Beta is nothing but electron emission or positron emission. Positron is nothing but antiparticle of an electron. When you say E0 minus 1, here the electron possesses a negative charge. Antiparticle of this electron is nothing but 1. This is positive, this is negative. Here mass is same. This may called as positron, this may called as electron. Electron, this is positron. So antiparticle. Likewise, there is any matter. If you consider any matter, there should be an antimatter. This is a fundamental phenomena of matter and antimatter. Now let us explain this concept in higher classes, not here in 12th standard. When you go to study about deeply about the radioactivity, then if there is any matter, there should be an antimatter. That's the thing that you are going to study in the higher classes. Now, to understand the radioactivity, these three concepts is mainly clearly you have to understand. That's a very important concept. Then at last, how can we explain with a suitable example? With a suitable example of alpha and beta. Alpha and beta. For example, when you say X, Z, A, this is an unstable element which are converted into Y, Z minus 2 and A minus 4 and plus 2, here 2, 4. It is nothing but helium particle. This is called alpha. This is called alpha. For example, let us consider uranium. Uranium 92, 238. Uranium 92, 238. Then becomes thorium. Thorium 88 and 234 plus 2He4. 2He4. We are adding these two, 90. 90 plus 2, 92. 234 plus 4, 238. This is the parental element. This is called daughter element. Daughter element along with the alpha particle. This is the alpha emission. This is the alpha emission, alpha decay. Okay. Here, the initial mass of this total is higher than this value and it may be converted as energy that may be emitted. The energy is equal to, given by the equation Q equal mz, mass of mz, mx, mass of mx minus mass of my plus or mass of minus m alpha minus m alpha into c square. This is the energy releases as per the Einstein mass energy equation. This energy which may be released during this process of radioactivity, that's why we are getting lot of energy. Here, parental element are converted into daughter element along with the alpha particle. That's the thing. Here, the mass into c square, E equal mc square. This is the Einstein equation of energy E equal to mc square. That is a very important concept to identify how much energy which are released during this process. This amount of energy are released due to radioactive substances of alpha decay. This is a very important concept to analyze the alpha decay. The first one, radioactivity, we are seeing alpha decay. The second one, next class we are going to see what is meant by beta decay. In alpha decay, it is nothing but helium nucleus of mass 4 and atomic mass number is 2. This must be along with the daughter atom, and lot of energy may be here. There may be lot of energy of Q along with this particle are happened. This is a radioactivity and the process. At last, they came to conclusion the phenomena of spontaneous emission of highly penetrating radiation which are produced during this process of radioactivity, and these elements are called radioactive elements, or if it's isotopes, radioisotopes. That's the thing that must be clear to analyze the concept. radioactivity, radioisotopes, radio elements. These things are very important. I hope you understand clearly about um, what is nuclear force and what is radioactivity and what is meant by alpha decay very clearly. Next class we are going to see about the beta decay and gamma radiation. Thank you, my friends.